This is question 3 from the SACE Stage 2 Physics course companion from Chapter 2.1 Electric Fields. We have charges Q1, Q2 and Q3 in the arrangement shown. Q1 has a charge of 3.5 microcoulombs, Q2 has a charge of 1.5 microcoulombs and Q3 has a charge of 2.5 microcoulombs. We are required to work out the magnitude of the net force acting on Q1 due to charges Q2 and Q3. The way we're going to do this is by using Coulomb's law and then adding the two forces as vectors to find the net force. So first let's work out the magnitude of the force acting on Q1 due to Q3. So here I'm going to write this as 1, 3 to denote the two charges is 1 on 4 pi epsilon naught Q1 Q3 on r squared, which is 9 times 10 to the power of 9. Our Q1 is 3.5 times 10 to the power of minus 6. We don't need to include the positive or negative in our calculations. It's better to understand the nature of the forces rather than trying to remember pluses or minuses here. We know that since it's a plus and the minus is going to be an attractive force, multiplied by Q3, which is 2.5 times 10 to the power of minus 6 here, remembering that micro means 10 to the power of minus 6 and they're separated by 0.65 millimeters. So there's another conversion to do here. So 0.65 milli is 10 to the minus 3. And if we substitute that into our calculator, we should get 1.86 times 10 to the power of 5 newtons. We can do the similar calculation, but for charge Q2, so that's 1.5 microcoulombs. So here, subscript 1, 2, using Coulomb's law again, Q1, Q2 on r squared. Here 9 times 10 to the power of 9, and we have Q1, which is 3.5 microcoulombs, and Q2 is 1.5 microcoulombs, and they are separated by 0.44 millimeters, so doing the same conversion. And if we substitute that into our calculator, we should get 2.95 times 10 to the power of 5 newtons. So here, it's a little bit easier if we draw a bit of a vector diagram. So here we have Q1, the force due to Q3 is directed downwards since it's an attractive force. The force due to Q2 is directed to the right because it's also an attractive force. So I can just draw that like this. 1, 3 and 1, 2. So the net force will be those two added together. So here, just using Pythagoras' theorem, that the net force will be equal to the sum of the two separate forces squared plus 2.95 times 10 to the power of 5 all squared. And if we substitute that into our calculator, we should get 3.49 times 10 to the power of 5 newtons. And we don't care about the direction because the question only asks us for the magnitude. And that's it. So it's just essentially two Coulomb's law calculations and then an application of Pythagoras' theorem to add them as vectors. It's fairly straightforward. The rest of these should be fairly easy.